I am Anil Kumar. Welcome to my series on solving equations. In this video, we'll discuss about how to solve linear equations. Some linear equations, like the ones which you see in first and the second row, can be solved in just one step. And then at times, we have to combine these steps. So we may have to combine these steps of adding or subtracting or multiplication and division, and we call them multi-step linear equation solution. Now these equations may also involve fractions, so we have taken up a few examples with fractions also. Basically, when I say solve linear equation, it really means find the value of variable. Find the value of variable. Now, in our case, for simplicity, I have used only x, but there could be any variable, right? So, in our case, it is find the value of the variable x to make equation true. Now, when I say to make equation true, here we see equality sign. So, left side should be equal to right side, right? So, this is sometimes we refer this to as left side, that will be right side of equal to sign. So both we have to make equal, only then we say that the equation has been solved. Perfect. Equation may have more than one solution or may not have any solution also at times, right? But in case of linear equations, we are looking for one particular solution. So for linear equations, most of the time we are looking for one solution. Okay, now let's take them one by one and understand how to solve linear equation. Now all these equations are linear mainly because the power of x is just 1, right? So therefore they are linear equations. Okay, so let's write that down. So power, or you can say degree, or you can also say exponent of x is 1, correct? So they are linear. So basically, if I say that we have an equation with x squared, then it becomes quadratic equation. If I have x cubed, it becomes cubic equation. Okay, something with like this, we'll call them radical equations. Okay, so just to complete the understanding of equation, there could be a variety of equation. When we are just talking about simple equations, there are many other types of equations. Okay, so let's see how to solve a linear equation. Let's begin with the very first one. We have x plus 3 equals to 10. Now one way is like intuition, right? You can say, well, what makes this true, right? So you ask the question, what makes this true? I know 7 plus 3 is 10, and so I say x is equal to 7. Now that could be one way of doing it, right? The other way of doing it was something like this. I have x plus 3 equal to 10. I could actually take away 3 from both the sides, right? So it is an equal to sign. So we need to do same things on both the sides. So I could take away 3 from both the sides. Now if I do that, what remains? X equals to 7, right? So what we get here is x, 3 minus 3 is 0, equals to 7. Now this is the method which normally we are going to adopt, right? This method of intuition may work with very simple equations, but later on we may not be in a position to solve with this method, right? So we'll kind of adopt to this method, and we'll also take a version of this. This could be modified. I'll show you here how. Okay. So let's again apply this method to solve the second equation. Right? So I hope the steps are clear to you. Right, so Now we are saying x minus 5 equals to 17. What should I do? Well, as I was saying, easy method is not by intuition, but just add 5. Now if I add 5, what happens? Well, if I add 5 and minus 5, that becomes 0. So we are getting x equals to 17 plus 5, which is 22. So 22 becomes the solution of our equation. Is that clear to you, right? Now at times, you may be required to check your solutions. So in case you want to check, you can substitute the value of 22 on the left side. So, well, the left side is 22 minus 5, that is indeed 17, and it is equal to the right side, so our solution is correct. So that is the kind of check which you might like to do at times, or sometimes the question will specify find solution and check your solution. Then this is what you need to do. Perfect. Now let's apply our technique here and solve this equation. We have plus 12, the inverse or the thing which could make this part 0 is negative 12. So we are going to add negative 12 on both the sides. Equal to means you have to do same operation on both the sides, right? Okay, so once you do that, what do you get? You get x equals to 4 minus 12, that is minus 8. So in solving equations, you could get negative answers. You could get positive answers, negative answers, any rational number or fractions as your answers. Correct? So that is how you actually do them. Now here is alternate method, which we are going to use many times in our examples. So let's look into another method which could be applied. So we have already learned two methods, right? So first method here was by intuition. You can say mental maths. Okay, so that was the first. Second, what did we do here? We did reverse operation, right? So in reverse operations, plus and minus, and you could also do times and divide by, which we'll take up in the next three examples. Now here is an alternate method. You must have noticed that end result of this adding or subtracting is that if I have this equation x plus 12 equals to 4, I could write directly as x equals to 4 minus 12. So what is happening here? I'm actually taking this 12 from the left side to the right side. So when you switch the side, then the sign changes. So when you are switching the side, this sign plus becomes negative. Do you see that part? So the sign changes. So you could do like this, which means the same thing. 4 minus 12. You get the idea, right? So that is our alternate method. And then we get x equals to minus 8. Perfect. So that is your alternate method, which is very popular and faster, right? Especially when we have bigger equations. Okay. So as an exercise, you should check your solutions, right? So let's check this one also. So on the left side, what do you have? You have x, and if I do minus 8, I do get, you have x plus 12, we have x plus 12, so x is minus 8, so if I do minus 8 plus 12, I do get 4, right? So that means this left side is equals to right side, and my solution is correct. Perfect. So that is how you actually solve and check. These are all single step solutions of linear equations, right? Single step mainly because we look into this step. X plus 12 equals to 4, so x is 4 minus 12, which is 8, right? Minus 8. So you could have written here, and that becomes a single step solution. Is that clear to you, right? Now let's take more single step solutions. Now in these, we have 2 times x equals to 14. half times x equals to 6. This could be also read as x divided by 2 equals to 6. And here we are saying 4x equals to 30. Let's see how to solve this. Now if I have 2x equals to 14, what could be my reverse operation? I could divide both sides by 2. So if I do that, 2 divided by 2 is 1. So I get 1 times x, which is x, and here 14 divided by 2 is 7 as my answer. Right? So now you can check this solution. So if you want to check it, then the left side is basically equal to 2 times 7, which is 14, same as the right side. So it is correct answer. You get the idea. So this is again a single step solution, right? Next one equation which we have here is, you could read this as x divided by 2, or you could also say half times x equals to 6. Now, in both sides, we could just multiply by 2, right? So if you do that, this 2 cancels, and we get our answer, which is x equals to 12. You get an idea. So we get the value of x as 12. You know, x, if it is replaced by 12, half of 12 is 6. So these equations balance out, kind of. Do you see that? So that's how we do it. Now here, 4x equals to 30. What should be the answer? Well, let's follow our steps. 4x equals to 30. I'm going to divide both sides by 4. When I divide, I get x here, and here I get 30 over 4. Now this could be simplified. We could divide both by 2 and write this as 15 over 2, right? Does make sense to you? So we can divide both by 2. So we get 15 here and 2. That could be your answer. So if you write like this, you're writing answer in fractions, but you could also write this as 7.5. Okay, so both are correct answers. However, most of the time this one is better or preferred. Correct? So if nothing is mentioned, you could write this. Now, at times, we could change this question and write this as write in reduced or the lowest terms. Right? So we might ask you to reduce it to the lowest terms. Now in this particular case, this is improper fraction, so you may also think about writing this as 7.5. Perfect? So those are all possible solutions, right? So this is correct, that is correct, and this is also correct if nothing is mentioned. Sometimes if I say write to 1 decimal place, that is your answer. Is that clear to you? So that is how we are going to write down the solution of our equations. Now let's look into equations where more than one step is required. Okay. So let's see the steps involved. We'll take 2x minus 3 equals to 17. The first step here should be, since this is minus 3 here, we want to get rid of it. So we will do plus 3 both sides. Right? So when you do plus 3 both sides, what do you get? You get 2x equals to 20. So that is our step number 1. Right? This is step 1. Now step 2 is what? Step 2 is to divide 2x and 20 by 2. So we have 2x equals to 20. We'll divide both by 2 and we'll get x equals to 10. You have your solution. Do you see that? So that becomes a 2-step solution. Is that clear? That's what we mean. So initially we did few examples with 1 step which involve this or that. Now we are combining both and that becomes 2-step solution, right? Or you can at times say multi-step solutions. Is that clear to you? Perfect. Now let's do the next one. Now this particular question, let me do it using the alternate method. So the alternate method you learned was, we have 3x plus 5, let me rewrite the question, equals to minus 10. We could take 5 to the other side, so we'll write this as 3x equals to minus 10 minus 5. Did you see that step? So we moved plus 5 as a whole to the other side and it became minus 5. Sign changes. Reverse thing. Just as we are doing the reverse operation. Perfect. So that is to say, we get 3x equals to minus 15 in our first step. Now, we can divide by 3, and dividing by 3 also, we could actually straight away write this as minus 15 divided by 3. There is no point showing this operation. We know the result. They get cancelled, right? They get cancelled. We are left with just x here. On the other side, this number goes in the denominator. So that's what we did. We straight away wrote x and divided minus 15 by 3. And now we could simplify this and write our answer as x equals to minus 5. Does it make sense to you? Now we are getting closer to our actual method of working, right? That is the way which we expect you to work with when you begin to use linear equations. Perfect? Now let's adopt this method here. This is slightly tricky. We have minus 2x, okay? So 4 is positive. See, this 4 is a positive sign and we are going to take it on the other side. It will become a negative sign. So in first step, we get minus 2x equals to 10 minus 4. Is that clear to you? Well, let's combine this and rewrite this as 10 minus 4 as 6. Now the second step should be dividing by negative 2. So we get x equals to 6 divided by negative 2, which leads us to x equals to minus 3. Positive quantity divided by a negative quantity should give you a negative answer. Perfect. Now you should check this out, right? So if you write minus 3 here, minus minus becomes plus, right? So what do we get? We get 4 minus 2 minus 3, right? So minus minus becomes plus. We get 4 plus 6, which is equal to 10. Does it make sense to you? So that is how you could check your answer also. I hope it is perfectly fine. These are involving fractions, and I'll show you a new technique to solve these questions. Now these 3 questions may involve very different technique. Fractions are indeed involved here. How should we solve it? The first question is x plus 3 divided by 2 equals to 8. Now what should we do? I think the better option could be in first step, in our step 1, we should multiply by 2 both sides, right? So we should multiply by 2. That should be our step number 1. So what we do here is, let me just show you. X plus 3 over 2 equals to 8 is our question. We will actually times by 2 both these sides, right? Both these sides. So that decimal is actually multiplication, okay? So when you do that, this 2 and 2 cancel. So we got rid of the fraction. What remains is x plus 3 equals to 2 times 8, which is 16, right? So that is kind of a very critical step. We got our linear equation without fractions, right? So step number 1 basically involves to get rid of fractions, right? So here, let me say our step 1 is get rid of fractions. Once you do that, then we do our multi-step program, right? Multi-step solution. So that becomes our second step. So now we have x plus 3 equals to 16. I could write this as x equals to 16 minus 3. So x is equal to 13. Does it make sense to you? So that is how we should be solving it. Correct? So let's check our answer. So if I replace x with 13, I get 13 plus 3 divided by 2, which is 16 divided by 2 is indeed equals to 8. So the left side is equal to the right side. Is that clear? So that is how we are going to solve equations which involve fractions. Correct? Now in this case there was only one denominator, so we just multiplied by 2. Now in this case we have two different denominators, 15 and 3. How do we solve this? Well, what number we have to multiply by is what we have to think about. That number is always the LCM, right? Lowest common multiple. So the lowest common multiple for 15 and 3 is 15. So we'll multiply by 15 both these sides. So you get this strategy, right? That is how we're going to do. So we have x plus 3 over 15 equals to 1 over 3. Both sides we are going to multiply by 15. So this 15 on the left side cancels, and here 15 goes but 5 remains. 3 times 5 is 15. So now we have an equation which is x plus 3 equals to 5. Now these are equivalent equations. They are same equations. Now we'll do the second step and we get x equals to 5 minus 3 and we get solution as x equals to 2. Correct? So that is how we are going to solve it. If I replace x with 2, what do I get? Let's check. So we get 2 plus 3 over 15, and 2 plus 3 is 5. 5 over 15 is indeed 1 over 3, which is the right side. So again, left side equals to right side, so our equation is properly solved. Correct? The last question here is, now we have denominator, the numbers 2 and 3. So what is the LCM now? The LCM is 6. So we're going to multiply each term by 6. Okay? So let's see how. So we get x over 2 minus 2x over 3 equals to 1. We are going to multiply everything by 6, right? What do we get? Now, the first term goes 3 times, the second term goes 2 times, and the third term we get 1 times 6, which is 6. So we could rewrite this equation as 3x, and that becomes 2 times 2, which gives us minus 4x, and here we get equal to 6. Now in this type of equation, we have another strategy also, which is called cross multiplication. We'll use this strategy in another video, and we'll discuss this in details in another video. But here I think you get a concept, right? So what is really happening? This 2 times 3 got crossed to that position, so that's kind of a cross multiplication. Okay, this was also a cross multiplication. We times 8 by 2. This was kind of a cross multiplication. 15 went there. 15 divided by 3 is 5. So that was a cross multiplication technique which was utilized, right? So you could think like that also. Now let's continue with our solution. We have 3x minus 4x equals to 6. 3x minus 4x is negative x, which is equal to 6. So x should be equal to negative 6. Perfect. So that is how we are going to solve this particular equation. So I hope now you understand the basics about solving linear equations. So let us summarize. When we say linear equations, in this case, the power of x is 1. That is very important. When we say solve, in that case we say find variable. So that left side is equal to right side. Clear? So these are the steps. And the last part always should be checked when you are beginning with, right? So once you get your solution, it's a good idea to check, right? So what we learned here is when we have an equation like this, we could either do minus 3, get our answer, or we could straight away write x equals to 17 plus 5 to get our answer. If it is multiplication type, then x equals to 30 over 4 is our answer. In this case, x equals to 6 times 2 is our answer. In this case, x equals to 14 divided by 2. So these are all single step, right? So these are one step solutions. Is that clear, right? In one step, you actually got the solution. Perfect. Now the other lot which we worked on involves two steps. In first steps, we are saying 2x is basically equal to, when you take there and add, it's 20. And in the next step, you say, well, x is equal to 10. So do you see concrete two steps involved? Perfect. So two steps, and then it could sometimes be multi-step, right? So we have taken very simple examples. So here it would be 3x equals to, when you take it to this side, minus 15. So what do you get x as? So x is equal to minus 5, dividing minus 15 by 3. So normally it doesn't take much time to solve them. You've seen how easy it could be once you get some practice, right? So it is minus 2x equals to 10, take away 4, which is 6. So what is x equals to? Well, it is negative. So don't forget that. 6 divided by negative 2 should be negative 3. Perfect. Now in these equations, we did cross multiply, and indeed, they will become multi-steps. So these were two-step solutions. And now we have multi-step, right? So first step is cross multiplication. Let me write here. And then we continue. So when you cross multiply, you get x plus 3 equals to 16. And then we get our answer, x equals to 16 minus 3, which is 13. Is that clear? Now in this case, you could actually simplify this and then cross multiply. X plus 3 equals to 5. That gives you x equals to 5 minus 3, right? So basically, see, x plus 3, 5 cross multiplies, right? And then we get x equals to 5 minus 3, which is 2. In this case, we have to take a common denominator. So you could write like this. This is 6, right? Here you have 3x minus 4x equals to 1. And that is minus x equals to cross multiply. And that gives you x equals to minus 6. Is that clear? So in short, once you get more practice, you will be able to solve like this all the linear equations, right? So that's encouraging. So now we can take up more questions related to solving multi-step linear equations involving more fractions. That would be interesting. Thanks for watching and all the best.